Okay, second half of day two, mutually exclusive outcomes. So essentially what we're talking about with mutually exclusive outcomes is when two things are going to occur and they cannot occur at the same time. So when you roll a die, you cannot roll a 3 and a 5 at the same time. That's mutually exclusive disjoint is another way of putting it. And that's basically what we're going to do today. And it's very, very basic, but it sets the groundwork for what's going to happen afterwards where it's not mutually exclusive. So probability of A or B happening when it is disjoint is just probability of A plus probability of B because it's the union of the two. A or B is the union of A and B. It's either or. And since it's exclusive, you can just add the probabilities up and it's very straightforward. As I said, when it's not mutually exclusive, that's when it gets a little more complicated. So this is very basic in comparison. So disjoint, there is no overlap in the two circles. So A and B are completely disjoint. They're mutually exclusive, and you can just do the probability of A plus the probability of B, and you've got the answer. All right, let's try some. If a committee of 5 is to be chosen randomly from 6 males and 8 females, what is the probability the committee is either all male or all female? So 5 is to be chosen randomly. So it's a committee. There is no specific positions, so it is a choose notation, not a permutation. It's combination, not permutation. So choose notation, and for males, you're going 6 males, you need to choose 5 of them, so 6C5. That would be your numerator. And for the females, it would be 8C5, and that would be your numerator. Now, your denominator in probability is all possibilities. So you've got 6 males and 8 females. That's a total of 14 people. Choose 5. That's your denominator. So A's female, B's male. The females we said is 8. Choose 5 because there's 8 females. And then 14 is all the people together. 6 males and 8 females is 14 total. Add the two together and you get your answer. Remember, adding fractions, you do not add the denominator, you just add the numerators. So there's your example number 1. Some situations, events are not mutually exclusive, which means that they can occur simultaneously, rolling an 8 or doubles. If you did the diagram for 2 die, you'd see that 8 happens to fall on the doubles. So you have an overlap. What are you going to do and have that? Well, it's A plus B minus the intersection because you don't want to double count it. You've included the double 4s when you did probability of A, and you've included it in probability of B, which means you've double counted it. So you need to subtract it once, which is the probability of A and B happening at the same time. And you subtracted that one time, and you're good to go. So the visual Venn diagram, you've got the overlap. Card is randomly selected from a standard deck of cards. What's the probability that it's either a spade or a face card? So spades, there are 13 spades in the deck, 13 out of 52. And face cards, there are 3 per suit, 4 suits, so 12 out of 52. So 13 out of 52, 12 out of 52. But how many spades are also face cards? You got to subtract 3 at the very end. So 13 spades, 12 face cards, minus 3 spades that are face cards at the same time that you double counted. last example. If you roll 2 dice, what's the probability of rolling a sum greater than 7 or doubles? So sums greater than 7, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. Looking at the above 7, so you got the 8s, the 9s, the 10s, the 11s, and the 12s. So you've got that part, 15, or doubles. The doubles are right down the middle, 2, 4, 6, 8, 10, and 12. So there's doubles is 1, 2, 3, 4, 5, 6. 15 plus 6 minus 1, 2, 3 that are double counted. So 15 plus 6 is 21, minus 3 is 18. That's 18 out of 36 is the answer. Suggested exercise is page 42.